It's an absolute pleasure to be here. As we just heard, we're going to try to talk a little bit about AI and how AI has impacted also the ability to use sperm as a biomarker. We monitor everything today. So I wear an Oura ring. I use that to track my sleep. I also wear a Whoop for strain. If you know, you know. Both of them have very different use cases. Every 6 months or so, I will also monitor my glucose levels to understand, what the foods that I'm intaking have in terms of impact on my general blood sugar levels. And a lot of you will also wear an Apple Watch. So there's a lot of things in life that we use to track our everyday health. One of the things that we don't track is reproductive health. I am 37 years old today, and it took me about 20 years of my life to learn how my, fertility worked. I froze my eggs I think I was like 30, 31 years old, and that was the first time I understood how different hormones impacted my own body, and that there was something called AMH, which allows you to measure your egg reserve. And at the time I went home and I talked to most of my girlfriends, I was like, hey, I just learned this, expecting them to tell me, hey, why did you not know this before? The reality was they also didn't know. And what I understood is that there's a really big lack in society of understanding fertility health. And I'm lucky because I'm German, and majority of Germans here, everyone in Germany almost, has access to healthcare. So it's quite a frequent thing that from the age that you hit puberty, you will go and see a gynecologist, once a year, maybe every 6 months. And so did I. And I lived in a lot of different places in Germany as well, so I saw a lot of different gynecologists. And the reality is, not once did one of them tell me anything about my fertility. And that's a problem, because in general, fertility is going into the wrong direction. We have 1 in 6 couples today who are experiencing infertility. And as we just heard before as well, as the sperm count has dramatically fallen, which means in the last almost 50 years, it has fallen more than 50%, to date probably close to 60%, with increasing decline since the 2000s. And one of the big problems is that fertility care is reactive, which means that a lot of the times couples will need to, try for 12 months, they will not seek help, and only once there is a problem, they will start testing. And what testing a lot of the times means is, you test by yourself maybe, you test a couple of different things, and then you will start seeing a specialist. And it takes a long while, until you actually see someone who can help. And a lot of times it will end up being an IVF treatment if you are looking to conceive a child. So in a lot of ways, we're losing years before we ever actually actively try and have a positive impact on fertility. So the big question that we ask ourselves is, can we do better? And is there something that we can do differently? And is there something else we can learn from fertility? And that being said, I'm really excited to introduce my co-founder, Dr. Hadi Shafiee. And I'll leave it to him to give you guys a little bit of insight as to what he's doing with his lab and what the science is and how AI can help us on the front. So you got the mic.
Thank you, Lara. So yeah, for the past 10 years, essentially, my lab has been focused primarily to address this problem when it comes to fertility management in IVF clinics. And I've been incredibly lucky to be able to work with really smart students, engineers, data scientists, and embryologists to develop digital health tools and AI frameworks with broad applications throughout IVF cycle, from semen analysis to ovulation detection, to embryo assessment, all the way down to quality assurance, embryo tracking, and embryo transfer. And I'm going to talk about a few examples just to give you an idea of what's going on. So when we say, what can we do about it, let's find out, first of all, what is the problem, okay? So in an embryology lab, one of the critical tasks that an embryologist do is to basically assess the embryo quality based on its morphology to make really important clinical decisions. For example, would you transfer this embryo? Would you biopsy? Would you cryopreserve? Or would you continue the culture? And To do that, basically, the embryologists look at these embryos under microscopic systems and manually assess the embryo quality. And so what we did was that we recruited 8 embryologists at Mass General Brigham and tasked them to evaluate the quality of embryos for these clinical decisions. Basically, what we observed was that there was a huge variations between what they made the decision. And that's a major problem because this decision is going to affect your clinical outcome. So then we wanted to find out if AI actually can solve that subjectivity issue. So we trained our basic model for doing embryo grading and tested that model along with 10 other embryologists to make 2 important clinical decisions. Would you biopsy this embryo or would you cryopreserve, right? And after that, we also rotated these embryos by 90 degrees, 180 degrees, and 270 degrees, and asked them to do exactly the same test, right? And what we observed was that there was a huge variability between embryologists and within the embryologists in terms of making those clinical decisions. And AI outperformed all of those embryologists in terms of consistently making that decision. Okay, so that was huge. AI consistency was 84% as opposed to 52 to 58% for human. But you could be consistently wrong. So what we did was that we moved to the next step and developed the AI models to predict the outcome in terms of embryo implantation. And we showed that our AI models could outperform embryologists. These are 15 embryologists across multiple clinics in the US. And we showed that we could outperform embryologists by a significant margin, 83% as opposed to 48%. So, and we did a lot of other interesting work around embryology, embryo assessment, embryo ranking, witnessing, tracking, and all that. I'm not going to get into that details, but this observation led us to a more interesting and difficult problem when it comes to fertility clinic. So there are these men who have almost 0 sperm in their ejaculate semen sample, right? And the common treatment for these patients is micro-TC surgery. So it's microtesticular sperm extraction, where the surgeon essentially has to take a biopsy of the testicle, and then the embryologists have to manually go through a very complex tissue microenvironment to look for really rare sperm. So imagine you have only 1 sperm in 1 milliliter of a micro-TC biopsy, which is buried under millions of other cells and debris and that's your one chance to become a biological father, right? It's a very sensitive case. So we wanted to tackle that problem by developing a software, hardware, AI system to be able to automatically scan a very large volume of micro-TC sample in order to find these really difficult sperm cells. We did that. The system is essentially a microwell device that helps you to process this complex micro-tissue sample, right? And then the AI system trained on millions of sperm images and micro-TC samples, can actually rapidly scan through this very complex microenvironment to find rare cells. We did that in less than 18 minutes in many cases. But what is really exciting here is that it's not like about automating the process. We found that in 90% of previously discarded micro-TC samples, there were ICSI viable sperm cells. So for these type of patients, essentially the alternative case was to go after donor sperm. if that makes sense. So we essentially expanded the threshold of biological fatherhood, which is really exciting. So the next one is automated semen analysis. We wanted to see if we can actually make a fully automated low-cost semen analysis for these IVF clinics. So semen analysis is the very first step for the man and couple that go through the infertility treatment, right? And these embryologists, essentially, they use these highly expensive, bulky microscopic systems in order to measure semen parameters like sperm concentration, motility, morphology, DNA fragmentation. And we wanted to see if we can actually develop something portable, low cost, decentralize it, right? So first, we focused on a smartphone-based optical system that costs less than $5 in terms of material cost to measure sperm concentration and motility. We did that and tested the system with 350 patient semen samples and showed that the system was able to classify normal versus abnormal semen samples based on WHO guidelines on sperm concentration and motility. Then, after we showed that, we tackled a much more difficult problem, which is like doing sperm morphology assessment, because the quality and the resolution of these type of data that you get with this $5 cell phone attachment is very low, that even embryologists cannot assess the sperm morphology of those type of data. And we did that. We showed that the system is really powerful with high accuracy, can measure all these parameters at low cost. So after 10 years of doing this type of technology development, what we realized was that the biggest opportunity for us may not be in actually the clinic, maybe outside of the clinic, before the patients actually come to the clinic, because several groups from Europe, in Denmark, and America, they reported studies showing that there is a good correlation between semen quality and your general health as a man, and you can use that semen parameters and semen quality to look as a window into your general health. So that led us to found Seedbox, and now I'm going to hand it to Avery as the CEO of the company to talk more in detail about the concept.
Thank you, Hadi. So if the biggest opportunity isn't in the fertility clinic, where is it? So it's right here. This is one of the largest studies of semen quality and longevity ever assembled, with 50,000 men being tracked, 80,000 men tracked over 50 years. And men with the highest level of semen quality lived over 80 years on average. And men with the lower level of semen quality lived 77.6 years. So that's a 2.7-year difference in lifespan based on just a sperm readout. And there's a 26 to 76% higher all-cause mortality with impaired semen quality, as well as an onset of chronic disease years earlier. And for those of you thinking maybe sick men have lower sperm quality, this survives adjustment and holds after controlling for prior illness. So Michael Eisenberg, who's the chair of urology at Stanford University, has said a men's sperm readout at age 40 predicts their death 30 or 40 years later. So it's a remarkable biomarker for overall health as well as fertility. So sperm is not just a static biomarker, it's something that's modifiable. It regenerates every 74 days. And when you change the inputs, the sperm signals actually change. So it's things like heat, nutrition, body composition, toxic intake, diet, alcohol, stress. And so it's something that's modifiable, measurable, and it's currently invisible to men who aren't tracking it. So as Laura mentioned, we have many devices tracking different biomarkers with current technology. For sleep, we use Aura, glucose, Dexcom, recovery, Whoop, heart rate, Apple Watch. But there's no market leader and no real product out there for men to test their fertility until now. So sperm has three properties that make it very unique and different from other biomarkers in consumer health. Number one, there are 4 readouts, not just one. So people often think We're just measuring sperm count, which is how a lot of devices in the industry today work if you buy something on Amazon or TikTok. So we measure concentration, motility, morphology, and DNA fragmentation. And each of these reflect a different biological system in the body. So temporal resolution. So sperm regenerates roughly every 74 days. So a single snapshot at a single point in time is fairly meaningless, but our device allows men to retest themselves and measure their sperm quality over time to see the trends and the effects from their behavioral changes. And then systemic correlation. Sperm quality is linked to cardiovascular disease, metabolic health, types of diabetes, and even all-cause mortality. So the sperm signal is not just about fertility, it's a window into overall health. From an evolutionary perspective, if something is going wrong with your sperm quality, likely something else is going on in your overall health, which is why you wouldn't be able to reproduce. So that's why it's an important biomarker for overall health. So I'll tell you a little bit about what each of these parameters mean. So concentration is sperm count divided by volume. And it's the strongest single signal. It tracks cardiovascular disease and metabolic health. Motility is the movement of the sperm. So it measures, is the sperm able to swim to the egg and fertilize the egg? It reflects cellular energy and oxidative balance. Morphology is the shape of the sperm. So are the heads and tails broken off, or are your sperm normally formed? And it reads oxidative stress and toxic load and shows the exposure burden on your body overall. And then DNA fragmentation reads oxidative DNA damage and cellular aging and is one of the clearest genomic markers of aging. And DNA fragmentation is a new parameter for sperm health that is often overlooked, but it's very important in understanding as a man if you're at risk of having a miscarriage. Basically, if your DNA fragmentation of your sperm is formed, it's likely that the embryo, the DNA within the embryo will malform, causing a miscarriage. So now that you understand that fertility is not just a biomarker, sperm is not just a biomarker for fertility, but a biomarker for overall health, you might be asking questions such as, why measure sperm quality only after a couple has spent thousands of dollars on fertility treatment and months or years struggling to conceive? Why only measure it inside fertility clinics? And why not measure it continuously like all the other biomarkers that are important to us? Introducing Seedbox. So this is the product that we're building. It's AI-driven, so it uses computer vision and optics to scan sperm cells at a microscopic level. Lab-grade precision, at home, no clinical visit or mail-in required, and no sample degradation in the back of a mail truck. It allows for continuous tracking, not a single snapshot. So this actually allows men to improve and optimize their sperm quality, not just get a one-time picture into their fertility health. So this is really important if you want to, for example, freeze your sperm. You might want to optimize it prior to paying a monthly subscription to keep it in a freezer somewhere. And built on a decade of reproductive AI research out of Harvard Medical School, commercialized and productized. So we're starting off by building an at-home reusable device that measures the 4 WHO parameters for sperm, along with a mobile app that coaches users on how to improve these parameters through behavioral and health changes. We'll evolve into a longitudinal male health tracking system that will sync with wearables and collect other data to give you a biological age based on your health signals. And in the long term, the company will evolve into the largest longitudinal data set of male fertility health signals, which will power clinical distribution, employer benefits, and reimbursement. So we're not just building a sperm test, we're building the infrastructure for male health. We think this is the right team to do it. It's the only team with Harvard science, global brand execution, and clinical hardware in one room. Sperm counts have dropped over 50% in the last 50 years, and most men aren't even measuring it. And we're here to change that. We're going to give men a window into their health like they've never had before. Thank you.
Yeah, we're really excited. If there's any questions, any insights, love to discuss as well. There's such smart people here that we've met so far, so we would absolutely enjoy any conversation. Thanks, guys. Yeah, in the round room. Thank you, guys.